Welcome to the deep dive, everyone. Ready to get into some CompTIA Security +5.
Always ready for a security deep dive.
You brought the exam objectives for the SY0-701. Let's unpack it, see what we're dealing with.
Yeah, the Security Plus certification is a big deal.
Like how big? What makes it stand out?
Think of it like a global passport in the IT world, really. Shows you've got that baseline cybersecurity knowledge, super valuable today.
Baseline, meaning, for someone working in IT, why does this cert matter?
Put yourself in the hiring manager's shoes. Pile of resumes, 2 candidates, similar experience.
But one has Security +I.
Bingo. Signals they're serious about security, understand the threats, can put measures in place, stands out big time, especially as attacks get trickier.
Not just a checkbox, proof you can handle the real deal.
Exactly. And this exam, it covers a lot T. Up to 90 questions, multiple choice. Some are performance-based.
Like simulating stuff, hands-on.
You got it. 90 minutes total. CompTIA recommends at least 2 years of IT admin experience, focused on security, though.
So, not straight out of school, you need some real-world chops.
Right.
Our document here, it breaks the exam into 5 domains, right? Each one a different piece of the cybersecurity puzzle.
Nice way to put it. All fits together for that well-rounded security pro.
Puzzle time, then. Domain 1, general security concepts. 12% of the exam, the foundation.
All about the basics. Different types of security controls, ways to protect systems and data. Layers, you know?
Not just firewalls, antivirus. There's more.
Way more. Those are technical controls, sure, but you've got managerial controls, too. Policies, procedures, the best practices.
Like company-wide security training. Gotta have that.
Exactly. Then operational controls. These keep things running securely day to day. Backups, recovery if something goes wrong, how you handle changes.
Making sure that plan actually gets followed, huh?
Yeah.
What about real-world stuff? Like,
Yeah.
are there controls for that, too?
Oh, absolutely. Physical controls, super important. Protecting buildings, equipment, even the people themselves. Guards, cameras, locked doors, lighting.
Security isn't just digital, it's the whole picture.
Right. Beyond that, Domain 1 has these core security concepts like the CIA triad. Familiar.
Sounds like a spy movie.
Close. Confidentiality, integrity, availability. The 3 pillars of InfoSec.
Okay, break it down for me.
Confidentiality means only authorized folks can see sensitive info. Integrity means the data is accurate, hasn't been messed with. And availability means that authorized people can get to the data when they need it.
So like keeping secrets, make sure no one's tampering, and keeping systems up and running.
Exactly. They're all connected, gotta have all 3 for strong security.
Makes sense. What other concepts are packed in here?
Non-repudiation is one, making sure someone can't deny they sent info or did something on the system. Accountability, think digital signatures, audit logs.
Gotcha.
Then the AAA, authentication, authorization, accounting. This is about controlling who gets access to what.
Sounds familiar, but give me an example.
Think of a club. Authentication's like showing your ID at the door. Authorization is the bouncer checking if you're on the list. And accounting is the cameras recording who comes and goes, keeping track.
Verify who you are, what you can access, and log it all.
Exactly. Super important for building secure systems. And there's more. Zero trust. How to really think about physical security and then all the crypto stuff.
Zero trust is a big deal these days, right?
Huge. Basically, you don't trust anything automatically inside or outside your network. Verify everyone and every device every time.
Even if you're already on the company network.
Yep. Prove it's you. The physical security stuff gets specific too. Bollards, those barriers you see, special entryways, fencing, how you use lighting and sensors. It's fascinating.
Fort Knox, digital edition.
And sometimes you put traps inside. Deception technology like honeypots. Fake systems to lure attackers in.
Bait to see how they operate. Sneaky.
Very effective. Before we move on, what about those crypto solutions? You curious?
Definitely. That's a whole world I barely get.
It's all about securing communication, even with adversaries lurking. Making sure info stays confidential, hasn't been altered, and you know who it's from. PKI, digital certificates, different types of encryption.
Phew. Domain 1 alone is a lot. This foundational stuff's no joke.
It's the groundwork. Gotta have it to really grasp the advanced topics later on.
Feeling a bit more prepared now, honestly, but that was just one domain.
4 more to go. Things get even juicier, trust me. Back for more deep diving. Good. Last time, fundamentals, the basics. Now let's get real world. Threats. The stuff you need to know, not just for the Security Plus exam, but to actually protect systems out there.
Right. Things get a bit more intense now. Domain 2, threats vulnerabilities, and mitigations. 22% of the exam, that's a big chunk.
It's huge EE because
Yeah.
you got to know the threat landscape. Who are the attackers? What do they want? How do they operate? It's like
Great.
cybersecurity chess.
I'm intrigued. Okay, so who are we playing against here? Who are these threat actors?
Individuals, groups, anyone trying to exploit weaknesses for bad stuff. The exam objectives, they break it down nicely. Nation-state actors, that's your government-backed groups, often. Spying,
The
sabotage.
Cloak and Dagger stuff?
Oh, yeah. Then you've got cyber criminals, plain and simple, money's their motive. Stealing credit card info, ransomware, all that fun stuff.
Fun for them, not for us.
Exactly. Hacktivists, they're driven by ideology, political statements, defacing websites, leaking info, disrupting stuff to get attention.
So organized crime, activists, and just troublemakers in general.
You got it. Oh, and don't forget insider threats. People within an organization misusing their access intentionally, sometimes not.
That's scary. Like, they're already inside.
Disgruntled employee, someone tricked into giving up their login, or just plain careless with sensitive info. Happens more than you think.
You mentioned threat actors exploiting vulnerabilities. What's that mean exactly?
A vulnerability is a weakness in a system, a process, anything, and attackers can use that to get in. Think of it like a crack in a wall.
So not just technical glitches, right? Human error, too.
Big time. The exam objectives, they talk about all sorts of attack surfaces, network services, applications, the OS itself, physical locations, even the supply chain.
That's a lot of potential cracks to worry about.
That's where vulnerability management comes in. Identifying, assessing, fixing those weaknesses before attackers get to them.
Constant checkups for the entire system.
Exactly. Now let's get specific. Application vulnerabilities like SQL injection, cross-site scripting, they exploit how apps handle data.
I've heard those terms, but
Yeah.
no clue what they actually do.
Okay, imagine a website, right? Search bar. You type something in, it searches a database. SQL injection is like sneaking malicious code into that search, tricking the database to spill secrets or even give you control.
Using the website's own tools against it.
Clever, right. Then you've got operating system vulnerabilities hitting the OS itself, taking control, installing malware, stealing data. Yeah. It works.
Yikes.
And the simple stuff, misconfiguration, default passwords, cloud storage not set up right. It's more common than you think.
Rookie mistakes with big consequences.
Absolutely. And then there's the human element,
Yeah.
social engineering, manipulating people to do the attacker's dirty work.
Oh, social engineering. That's a whole other deep dive.
It is. Phishing emails, those targeted spear phishing attacks, baiting, pretexting, all about tricking people into clicking bad links, downloading malware, giving up passwords.
I'm going to con artists went digital.
Exactly. And it's effective because it preys on human nature, not just tech weaknesses. The exam also covers hardware vulnerabilities, problems with virtualization, cloud-specific stuff,
So no matter where the data is, there's a way to mess it up.
pretty much. And then there are zero-day vulnerabilities. Brand new, nobody's patched them yet, super dangerous, attackers get a head start.
A race against time to fix it before they exploit it.
You got it. Now, once you know about the threats, the weaknesses, gotta analyze indicators of malicious activity. Be a digital detective.
Sounds fun. How do we spot those clues, the digital fingerprints?
Imagine you come home, doors ajar, footprints, something broken, a weird smell. Those are indicators. Cybersecurity is the same. Unusual network traffic, changes to system files, accounts locking out for no reason.
Red flags popping up.
Exactly. The more you find, the more likely it's an attack, and then it's mitigation time.
All right, let's stop these bad guys. How do we do it?
Lots of ways, all important for strong security. Segmentation is one. Divide your network into smaller chunks, isolated.
Damage control if one part gets hit.
Exactly. Access control, that's huge. Limit who can touch sensitive data based on least privilege, only what they need to do their job.
Need to know basis.
Yep. Application allow listing. Instead of blocking everything bad, you say what's allowed. Everything else is blocked by default.
A whitelist approach.
Love it. What about when a system's already compromised?
Oh, good question.
Isolation. Quarantine that system, stop the spread, then you clean up, restore it to a safe state.
Like a digital hospital.
Perfect analogy. Patching, that's essential. Updates to fix those known vulnerabilities.
Like getting your flu shot.
Exactly. Stay up to date. Attackers are always looking for new ways in, so vendors are always patching. It's a never-ending cycle.
No rest for the wicked or the security pros.
Right. And patching isn't enough alone. You need those other layers. Firewalls, intrusion detection systems, antivirus.
The classics. Remind me what they do exactly.
Firewalls are the gatekeepers, controlling traffic between networks. Intrusion detection systems, they're like security cameras watching for suspicious stuff. And antivirus, it scans for those known malware signatures, tries to block or remove them.
A whole security team working together.
And don't forget encryption. Scrambling data so unauthorized folks can't read it, data in motion, data at rest. It all needs protection.
This is a lot, even for this deep dive. How can anyone keep track of all this?
It is a lot. The Security Plus exam, it's not about being an expert in everything. It's about understanding the big picture, the concepts, the principles.
Like learning a new language. Start with the basics, then get more fluent.
Great way to put it. And this, sir, it's just the beginning. Cybersecurity is always changing. Got to keep learning, keep adapting.
Man, this domain, too, has been eye-opening. Threats, vulnerabilities, how to fight back.
We've only scratched the surface. 3 more domains to go, each with its own twists and turns.
Welcome back to the deep dive. We've laid the groundwork, explored the threats lurking out there. Now, let's build some defenses. Time for security architecture.
You got it. Domain 3, 18% of the exam, all about designing secure systems from the start. Like an architect, but for the digital world.
Love that analogy.
Yeah.
So where do we even begin with something this complex?
Well, the exam objectives point us to a few key areas. First up, understanding those different architecture models and how they impact security. Cloud computing, on-premise, those hybrid setups.
It's not just servers in a basement anymore. We've got cloud, mobile, everything connected.
Exactly, and each model has its own security quirks. Cloud computing, you're trusting a third party with your data, right? So that shared responsibility model is key. Both you and the provider have got to do their part.
Shared responsibility can get confusing. Got to make sure you're holding up your end, even if the data is not on your servers.
Absolutely. And then data sovereignty. Where's that data physically located? Legal stuff, regulations, that all factors in.
Picking a cloud provider is just the first step. It's way more complex than that.
Right. Now, no matter what environment you're dealing with, there are fundamental security principles that always apply. The objectives stress that applying those principles to your whole infrastructure.
Okay, give me some examples. How does that look in the real world?
Firewalls, for starters. They control the traffic flow, right? Got to configure those rules carefully, allow the good stuff, block the bad. Secure communication protocols like TLS, SSH. They encrypt data in transit, so no eavesdropping.
Building the walls and then secure tunnels for communication.
Nice. And never forget access controls. Who gets to see what? Least privilege, that's the idea. Role-based access, maybe multi-factor authentication, even biometrics for something.
Layers of security, harder to break through.
Exactly. Now, Domain 3 also dives into protecting data itself. It's often the most valuable asset, right? Got to keep it safe.
Data protection, that's a huge topic. Where do we even start?
First, classify that data. How sensitive is it? What's the value? Not all data is created equal. Customer credit card info needs way more protection than, say, a public blog post.
Prioritize based on how bad a breach would be.
Right. Once you know what you're dealing with, apply the right controls. Encryption, always. In transit, at rest. Data loss prevention tools. Maybe even masking some data elements to hide the sensitive stuff.
So it's not just access control, it's about preventing leaks, making sure the data itself isn't messed with.
And then backups. Disaster recovery. What if everything goes wrong? Compromised systems, natural disaster. Got to have those backups and a plan to get back up and running quickly.
Like insurance for your data. You hope you never need it, but got to have it.
Couldn't have said it better. Domain 3 also gets into resilience recovery.
Okay, what's that about in this context?
Building systems that can take a hit, A&D bounce back fast, redundancy, failover mechanisms, even systems that can sort of self-heal.
Minimizing the damage, even if an attack succeeds.
Exactly. And making sure you can get back to normal ASAP. Now, beyond cloud, on-premise, hybrid, the objectives also mention virtualization, containers. Familiar with those?
I've heard the buzzwords, but not sure I really get them.
Virtualization, you're running multiple virtual machines on one physical server. Efficient, but it adds new security wrinkles. Got to secure the hypervisor, that's the software managing it all, and make sure those virtual machines are isolated from each other.
Like apartments in a building. Each one needs its own locks. Tenants can't just wander in.
Great analogy. Containers are similar, but even more lightweight. They share the same OS kernel, but the applications are separated.
So rooms within an apartment, each with its own purpose, its own rules.
Exactly. Secure the container images, the code and all that. Make sure they're isolated from each other. A&D, the host OS.
It sounds like these technologies, they offer a lot, but security gets tricky.
It's a trade-off, and the challenges keep evolving. Got to stay on top of best practices, keep evaluating, improving your architecture.
It's a living thing, got to adapt to survive in this threat landscape.
Well said. Which brings us to our final domain, Domain 5, Security Program Management and Oversight. The big picture stuff.
This is where it all comes together, huh?
It is. This is strategic. Making security part of the organization's DNA, not just a bunch of tech you bolted on.
More than just firewalls and antivirus, it's a mindset.
You got it. Governance, risk management, compliance, incident response, even training people to be security aware.
Whoa, that's a lot to cover. Let's start with governance. What does that mean?
It's the framework for making security decisions. Roles, responsibilities, policies, procedures. Who's in charge? How do things get done? How do we stay accountable?
Like checks and balances for security.
Exactly. Starts with understanding the organization's risk appetite. How much risk are they comfortable with?
Right, because security always costs something. Can't eliminate all risk, but you could manage it.
And that's where risk management comes in. Identify, assess, mitigate those threats. The exam objectives really stress knowing this process.
Walk me through it then.
First, find the threats. Threat modeling, looking at security logs, staying up to date on the latest news.
Knowing what's out there, what could hurt you?
Then assess. How likely is this threat to actually happen? What's the impact if it does?
Playing the what-if game.
Love it. Once you've assessed, you build mitigation strategies, technical controls like those firewalls, or administrative ones like policies and procedures.
A plan for when those what-ifs become reality.
And of course, gotta keep monitoring, adjust as needed. Risk management never really ends.
Constant improvement, the security version.
Now, risk is tied to compliance. Laws, regulations, industry standards. Gotta follow those rules too. The objectives hit on that, knowing the requirements, implementing controls to meet them.
Not just protecting yourself, but meeting those external obligations.
Yep. Compliance can be messy, different rules for different industries, different places, but it builds trust with customers, partners, regulators.
It's a badge of honor, showing you're doing things right.
Now, even with great architecture, perfect risk management, and compliance nailed down, incidents still happen. That's life. So incident response is crucial.
Okay, what's involved there?
It's a process. Detect, contain, eradicate, recover, and then analyze what happened. The objectives want you to understand this life cycle, having a plan ready.
Cybersecurity fire drill. Practice makes perfect, right?
Exactly. Minimizes damage, helps you bounce back faster. And finally, you need security awareness training for everyone. Employees, the whole team.
People are the weakest link, right? They make mistakes.
They can be, but they can also be your best defense. Train them right. They're your eyes and ears, spotting suspicious stuff.
Turning them into assets, part of the solution.
Exactly. Phishing, social engineering, password security, even physical security basics. Got to cover it all.
Building that security culture top to bottom.
Well, we've covered a lot today, haven't we? CompTIA Security plus, it's vast, always changing, foundational stuff, architecture, how to manage the whole program.
My brain's full, but in a good way. Feeling inspired to dig deeper.
That's the spirit. Cybersecurity is challenged, but it's so rewarding. You're protecting people, organizations. It matters.
Great way to put it. Listeners, if this deep dive got you thinking about a career in security, explore it. The Security Plus cert is a fantastic place to start.
And the learning never stops. Stay curious, stay informed, stay safe out there.
Thanks for joining us on the deep dive. Until next time, everyone, stay secure.